This section on compound inequalities involve more than one inequality at the same time. And by so doing, we can define certain intervals of numbers which satisfy certain kinds of real problems. So we'll edge into all that, but first of all I wanted to talk about the distinction between the mathematical distinction, that is, between the words and or. All right, so and, or, and if you think, well, that's kind of silly, you know what those mean? Yes, they are conjunctions. They link two phrases together. But in mathematics, there's a specific logical way to interpret these. And when you're talking about the word and, an and statement can only be true when all parts of it are true. So let me give you an example. The sky is blue and the grass is green. That's a true statement, isn't it? Because both parts are true. Now if I said the sky is blue and the grass is red, we would consider that a false statement, because one part of that is false. Obviously the grass is red version is false. And if everything is false in an and statement, then the whole statement is false. So if I said that balls are square and the sun is green, both those statements are wrong, and so that statement, and statement, is also wrong. All right, well, let me show you how that translates into what we're doing. And so suppose you were given this collection of numbers that says that x is less than 1 and x is greater than -2. What does that mean? All right, well, x is less than 1 involves all the numbers to the left of 1, and x is greater than 2, -2, I'm sorry, -2 means all the numbers to the right of -2. So if we're going to combine these into one statement, then we want to know what numbers satisfy both these conditions at the same time. In other words, again, there we go. In order for an and statement to be true, both parts must be true. So combined together, this would say all the numbers that are less than 1 and also greater than -2, and that would end up being this graph. And so really it's an intersection of these two graphs. If I wrote these together in one number line, we have numbers to the left of 1 and to the right of -2. Where do they cross? Where do they intersect? That is an and statement. So let me erase this stuff up here, because normally you would interpret this statement on a number line in that fashion. So let's talk about that. Where's the number between -2 and 1? How about 0? Is 0 less than 1? That's true. And is 0 greater than -2? That's also true. So it falls in there. What about a number over here, like 2? Is 2 less than 1? No, that's false. Is 2 greater than -2? That is true. But because it's false, it lies outside of my interval. All right, so here we are. This statement translates down to there. Now, the problems normally don't come to you this way, or situations sometimes don't come to us this way. Sometimes they come to us as a compound inequality. So this statement would be, at least in this course, would be more likely to be written this way. -2 less than x less than 1. And so when we have three parts with two inequality symbols, it's a compound inequality. It's one type of compound inequality. And it really, you think of it as two separate inequalities. this part reads x greater than -2, and this part reads x less than 1. And so now I prefer to think of this as being sandwiched. X is between -2 and 1. So to me, this is informally, I call this a sandwich inequality. But indeed, x falls between -2 and +1. As far as writing it with interval notation, we would say x belongs to the interval, left parentheses, -2, comma, 1, close parentheses. So I'm using parentheses because I don't have less than or equal to's there. So, and that's why I also have the open circles. All right, so these inequalities, which is what you're going to work with primarily, one of these types you're going to work with, will look like this. It won't look like this, but this implies an and situation where -2 is less than x and also x is less than 1. So it would be very possible to come up with something rather impossible. And so if you're careless about solving a compound inequality, it very well you could get something like this. Suppose you ended up with 1 is less than x, which is greater than 2. All right, so let's see. How in the world do we interpret this? Well, 1 less than x means that x is greater than 1. X is greater than 2. Okay, so I guess this probably means x is greater than 2. But it's kind of crazy because how do you go from 1 to 2 here? So I would be real careful, leery about that kind of situation. If you end up with a problem where these inequalities are not going in the same direction, then you may have probably have made a mistake somewhere in solving. So careful about those. We can devise some funny, I call them funny not in the sense of humorous, but kind of quirky inequalities. For example, if you said that x is greater than 7 and x is greater than 1, what would that mean? Well, this is all the numbers that are both to the right of 7 and to the right of -1. And so, being an and statement, your solution has to satisfy both at the same time. Well, if that's the case, that drawing doesn't really depict what's happening, because the only numbers that are both greater than 7 and also greater than 1 at the same time are the numbers greater than 7. And so this is kind of a quirky inequality, and your current textbook has a handful of these kind of strange inequalities. Let me give you one more in case you run into it. Now, I have tried to steer you away from those problems, I believe, with my practice problems I've suggested in my book. And by the way, if you're using my website has not been updated to the latest textbook edition, the 4th edition, and so those practice problems don't always match up. I need to fix that. But if you don't have a copy of my book at home, then if you're using the website, you might want to email me, and I'll give you the right practice problems.